Baby Shawties, welcome to our last video lesson here for Chapter 10. What we're going to look at today is kind of dig a little bit deeper and into parallel and perpendicular lines. And our goal is to kind of combine some of the skills that we've learned throughout this year, such as like equations of lines, possibly the distance formula that we learned in Chapter 8, solving systems of equations that we learned in Chapter 5. So a bunch of different things, and what we're going to be looking at today is kind of making the connection between these parallel and perpendicular lines, but then also using some of the skills we learned about before. Kind of to look into more detail on why lines are parallel, why lines are perpendicular. If we remember back to when we introduced the concept of a line, that all lines can be expressed in what's called slope-intercept form. That all lines will have two primary properties. First, M, which is called the slope. And if you guys remember, the slope represents the rise and the run. The rise describes how far the line goes up or down versus how far it goes to the right. And then you also have the y-intercept. And the y-intercept explains, again, where that line is going to cross the y-axis. So if here's my two axes and I had a line drawn, that y-intercept is going to cross that point there. So these are some properties of lines that we talked about early on throughout this year. So what we're going to focus on first is what really makes lines parallel and what makes lines perpendicular. So obviously parallel lines, as we should know, parallel lines are two lines that do not intersect. So the thing that makes them parallel, the thing that makes them not intersect, is the slope of those lines. So anytime you have two parallel lines, they're always going to be parallel if and only if, and this is the key thing that we're going to focus on today, they have the same slope. That means if I were to have two equations of lines, say y equals mx plus b for one line, and let's say I had a second line, y equals mx plus b, the thing that is going to be the same about those two lines are the slope. They're going to have the same slope. The only thing that's going to be different about them is where they start, and that would be that y-intercept. So anytime you have parallel lines, they are parallel because they have the same slope, which means that they go up or down and over the same amount, which means they're never ever going to cross each other. So whereas perpendicular lines are going to intersect, and they're going to intersect specifically at a 90-degree angle. So they're not just random intersecting lines, but they intersect at that special angle. Now the reason why two lines are going to intersect and be perpendicular to each other is also going to be related to their slope. So we're going to look at today what it means for two lines to be perpendicular. And again, it's going to look at their slope. So if we have two parallel lines, again, their slope are going to be the same. But what happens if they're perpendicular is that the product of their slopes is going to equal -1. Now this is going to be a little bit sassy, but what it means is that if I were to take, for example, the blue line, say call that M1, look at its slope, and I were to multiply its slope by the red line, call that M2, what I should get is -1, all right? And essentially what this is, kind of the fancy way of saying this, is it's called an opposite reciprocal. Okay, now this is not something we're going to focus on too much for today, but here's what it means. Let's say that I say that the red line has a slope of 1/2, and let's say that the blue line is going to have a slope that's an opposite reciprocal. So the word opposite means that since my red line has a positive slope, the blue line is going to have a negative slope. And the reciprocal is going to tell us that if my slope is 1/2, I'm going to tape that fraction, I'm going to flip it, which means the reciprocal of 1/2 would be 2/1. Now, why this works up here, that if I multiply the two slopes and I get -1, is if I were to multiply these two fractions together, what I would get is this. The top numbers, 1 times -2, would give me -2, and the bottom numbers, I would have 2 times 1, which would give me +2. So -2 divided by +2 would give you -1. So this is the rule that we're going to use today. So if we ever talk about perpendicular lines, we're going to use the fact that perpendicular lines are going to have slopes that multiply to -1, where parallel lines are always going to have the same slope. Okay, so in our first example, we are going to take kind of an example we did last section in 10.4. We're going to find the distance from a point to a line. Now, if you remember, anytime we want to find the distance from a point to a line, that the shortest distance, when we ask this question, we're going to try and find the shortest distance. And the shortest distance is always going to be the perpendicular distance. So when I say we're going to find the distance between that point and a line, our goal is to find the perpendicular distance. Now again, in order to find the distance, we're always going to need 2 points. And this goes back to what we learned about in Chapter 8. That to find the distance, we're going to use the distance formula, which again takes the coordinates of x1, y1, and x2, y2, and it's going to find the distance between those points by looking at the coordinates for both the x's and the y's. And using this formula again, we can find the distance between any 2 points on a graph. Now the key thing here is that we're going to have to find 2 points. We already have given to us 1 point. We know that we have the point of 1, 0. So our goal is we have to find another point on the line to find that distance. Now here's the only pickle, is that if we want to find the distance, we want to find the shortest distance, which means we need to figure out what is the perpendicular distance. So that means what we're going to have to figure out is we need to find a line that is perpendicular to this blue line that would go through that point of 1, 0. Okay? Now, how are we going to do that? Well, first of all, we have a point already. We know it's going to go through that point, but what we have to do is find a line that is perpendicular to the line y equals negative x plus 3. So to do this, what we're going to do is we're going to look at this first line that's given to us. Y equals negative x plus 3. And understand that from that, we're going to use the idea of slope. That what we said in our previous slide is that any 2 perpendicular lines will have slopes that multiply to negative 1. That means the blue line that's shown on the graph would have a slope of negative 1, so that when I multiply that by the slope of the red line that I'll draw, what we should get is negative 1 out of that. Now this kind of sets up a little equation. Okay, so in that box, let me just plug in an m for the slope of that red line. In order to find out what that slope is, let me just do some inverse operations. Let me take this and divide both sides by negative 1. That would cancel out on this side and leave me with m equals negative 1 divided by negative 1, which would give me 1. So what I know is that in my new line, I will have the slope y equals 1x plus something. Okay? Now, my goal is to figure out what is the equation of that line so that I can draw it on my graph. But I do know that it's going to have a slope of 1. The only thing I got to figure out is what is the y-intercept. Okay, now this is, again, utilizing a lot of stuff that we've learned already up to this point. I know that my slope has to be 1, and I also know that it has to go through the point of 1, 0. So this right here is what's called slope-intercept form, but I want you to remember that there was also what's called point-slope form. Point-slope form is used anytime you have the slope of a line and a point that falls on that line. And point-slope form looks like this. Y minus y1 equals m times x minus x1. Where again, y and x are our variables, our inputs and our outputs, m is our slope, and then x1, y1 are the coordinates of the point. So if I were to use what we have, what I would have is y minus my y value, which is 0, equals m. M is my slope, which we just figured out is 1, times x minus the x value from my point, which is 1. And again, I kind of skipped over this, and I apologize, but again, this is going to be my x1 and my y1 when I plug that in. Now, when I simplify, y minus 0, that doesn't do anything, so I get y. Then I'm going to distribute that 1. So I would get 1x, and then 1 times negative 1 would give me minus 1. So I know that my red line would look something like this, 1x minus 1. So if I were to graph that line, I would start from negative 1, and then I want to apply my slope. And my slope here is 1, which technically means 1 over 1. So I would go up 1 over 1, up 1 over 1. And notice that when I do that, notice how it goes through my point of 1, 0. So this red line would have the equation y equals 1x minus 1. Okay? Now, why is that important? Is because now I know that this red line is perpendicular to the blue line. And that's what was making this problem a little bit tricky, is I have to find the perpendicular distance. Okay? Now my goal is to find the distance from this specific point to that line, which means, and I'll highlight this here in green, I essentially want to find this distance right here, okay? I want to find the distance between these 2 points. So that would be a point of 1, 0, which is given to you. And then the second point, which would be right here. Now, real quick, as we obviously are graphing this, we can see that this point is going to have coordinates of 2, 1. Okay, so that is what I am going to use when finding the distance. However, this is helpful when I show you guys the graph, okay? So what if then we don't have a graph and we can't visualize this? How do I actually figure out the point where these two lines intersect? How would I find the intersection of the red line and the blue line? So to do that, anytime I want to find where two lines intersect, what I can use is some tricks and trades we learned about when solving systems of equations. That if I want to essentially solve these two equations together, that my answer, the point that I get, is going to be with a point where those two lines intersect. Here's what I mean. So I have my two equations, and I'm going to kind of create a new page here so we can see. I have negative x plus 3, and I have x minus 1. So again, my two equations are negative x plus 3 and x minus 1. Okay? So these are the two equations that we're going to use. So again, I have y equals negative 1x plus 3, and then my red line was y equals 1x minus 1. So when I want to figure out the point where they intersect, what I'm going to do is I'm going to take these two equations and I'm going to set them equal to each other. I'm going to take the negative 1x plus 3 and the 1x minus 1. I'm going to take those two chunks and I'm going to set them equal to each other, and I'm essentially going to solve a system of equations. Okay? Now to do that, again, think of my equation. I have the left side and the right side. What I would need to do in this problem is I got to combine my variables to one side and combine my numbers to one side. So let's say I take this minus 1x and I add that to the other side so that it cancels and I get 2x on the right side. And let's take that minus 1 and add it to the left side so that I would get 4. Now I have 4 equals 2x, so then if I divide both sides by 2 to get x by itself, 4 divided by 2 is 2. So that means in my point, my coordinates are going to be 2, comma, and then I got to figure out the rest. So to figure out the rest, if you remember back from solving systems of equations, I'm going to take this x equals 2, and all I got to do now is plug it into one of my equations. So let's say that I plug it into the blue equation. Whoopsies. So I'm going to have, for example, y equals negative 1 times 2 plus 3. And I plugged 2 where x goes. So then if I simplify this, I would have y equals negative 1 times 2 would give me negative 2 and then plus 3. And then lastly, if I do negative 2 plus 3, I would get y equals 1. So that means my y value would be 1. So the coordinates I would get here are going to be 2, comma, 1. And that is going to be the point where the two lines intersect. So the last thing that I need to do here is this. I know that the point that we were given was 1, comma, 0. I know that the two lines intersect at 2, comma, 1. So what I want to do is I'm going to use the distance formula to now figure out what is the distance between those 2 points. And I know that those two lines are perpendicular because I already figured out that slope multiplying to minus 1. So now if I just take these 2 points, okay, I'll take that x1, y1, x2, y2, and just plug them into the distance formula, it's going to give me the distance between those 2 points. So plugging those things in, the distance would equal the square root of x2 minus x1 would be 2 minus 1 squared, plus the difference between the y values, which would be 1 minus 0 squared. And again, I'm just plugging in the values for my points. Then to simplify, I'll just start off inside, and again, I'll simplify 2 minus 1, which is 1 squared, 1 minus 0, which is 1 squared. And simplifying more, then I would get 1 squared and 1 squared. Both of those are 1. 1 plus 1 gives me 2. So then I would get the square root of 2. Okay, and the square root of 2 is my exact answer. Otherwise, as a distance, I would get 1.41, depending again if you're asked to round that answer or if it's asking you to get the exact answer, okay? So we're going to get about 1.41 there as the distance between that point of 1, 0 and the line. So notice a lot of meat and potatoes in this one example. We had to use the idea of what it means for lines to be perpendicular. We had to then go back and use the idea of solving systems of equations to figure out where the lines intersect. And then we had to use our distance formula to solve. So this is a little sassy. So here's what we do. In this type of problem, I'm going to just jot down the steps for you guys. So step number 1, what we needed to do was find the slope. Okay? And we had to find the slope of the perpendicular line. All right, second thing that we had to do was then we had to write our equation. I'll just write EQ for equation. And we used point slope form. Okay, so that's point slope form that we learned way back in like chapter 4. Okay, so we found the slope of the perpendicular line. We then wrote the equation. Okay, then what we did is we technically then solved a system of equations. Okay, and to do this, kind of a quick little note is that we just set the equations equal to each other. And then we solved. Okay, and what we got there was a point. And the last thing we did is we used the distance formula to figure out the distance. So those are kind of the steps we had to follow. A little bit sassy, okay? A lot going on because we're applying a lot of concepts all in one. So make sure you jot these steps down. I know it's not the prettiest in steps, but jot those down when solving this problem. All right, now this next example is going to be just as lengthy. The only difference now is instead of going from a point to a line, we're going to find the distance between two lines. So a very similar problem, but slightly different. Okay, so I have here the two lines y equals 1/2 x plus 3 and 1/2 x minus 2. So I want you to notice, first of all, notice the slope of the red line is 1/2. Slope of the blue line is 1/2. So real quick, I know that those two lines are going to be parallel. Okay, now I just have a graph here, so I'm going to plot these for you. So here is the red line. I start off at plus 3. And then 1/2 again means that I'm going to go up 1, right 2. So from that point, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. I could go down 1, left 2, and so on and so on. All right, and I'm just going to draw my line. That's my red line. The blue line is going to be the same kind of thing. The only difference is it starts at -2. But again, notice that when you have the same slope, they're both going in the same direction. And because the slope is the same, these two lines will never, ever, ever intersect. Okay? So in this problem, what we want to do is we want to find the distance between these two lines. To find the distance again, so our goal here is to find the distance, we need to find what's called the perpendicular distance. Okay, so to find the perpendicular distance, we need to find a perpendicular line. But in this case, to find the distance between these two parallel lines, we need to find a line that's perpendicular to both of them. Now to do that, I'm going to use the idea of slope again. So what I know is that the slope of my two parallel lines is 1/2. Okay, so perpendicular means this, and I'll just show us in red. Let's say that I'm going to use the red line. I have a slope of 1/2. I'll call this new perpendicular line, let's draw it in green, that the slope of my perpendicular line and the slope of my red and blue line should multiply to -1. Okay, so I need to find the slope of a line perpendicular to the red and the blue. Now the red and the blue both have a slope of 1/2, so I'm just going to choose the slope of the red line. Okay, now to solve this, I obviously got to get rid of the 1/2. Okay, so I'm multiplying by 1/2, so a simple way to do it is divide by 1/2. Now, it's not really the best thing to do is to divide by fractions, but if I were to take that -1 and divide it by 1/2, and it's going to be the same thing as taking -1 and multiplying it by the reciprocal, which is 2/1, what I'm going to get for the slope of my green line is going to be -2/1, which just simplifies down to -2. Now here's the neat thing about this, is that this -2 is going to be the slope of any, when I say any, I mean any perpendicular line to these two parallel lines, okay? Now the tricky thing is that this is the slope, but where are we starting from? Think about the last example we did. We went from a point to the line. So what we have to do if we want to find the perpendicular distance is we have to choose a point. So what I'm going to do is to find the distance, I'm going to pick a point that's on one of the two lines already. I'm going to do the red line. So I'm just going to pick a point. I'm going to pick that one right there. Why did I pick that point? Is that because that's a really easy point to pick, because it's just simply our y-intercept. I know even from my equation that this is a y-intercept of 3, so that technically this is a point of 0, 3. So what I'm going to do is I'm going to go back to what I did in the previous example. I'm going to follow those same steps. I now know the perpendicular slope of -2. I now have a point. So what I'm going to do to find my perpendicular line is I'm going to use point slope form. Okay, so plugging in my values, I know it's y minus my y value, which is going to be the 3. And that's going to be, so y minus 3 equals then -2 times x minus, and again, this 0 is going to be my x1, so it would be x minus 0. And then my goal is to simplify. So I'll start off by distributing that -2. So I'd get -2x, -2 times 0 would be 0, and I'm just going to keep that minus sign. Then I have y minus 3 equals, okay, then I'm going to add the 3 to both sides, and again, 3 is my number, so I'm going to combine over there. And now what I get is y equals -2x plus 3. So this is going to be the slope of my perpendicular line. Okay, now notice the y-intercept is also plus 3. Well, that's interesting. So I'm going to draw this line on my graph. Starts off at plus 3. Now my slope of -2/1, remember what that means is down 2, right 1. So from this point, I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, and so on and so on. Heck, I could go up 2, left 1 if I wanted to. So my green line is going to look like this, okay? Now what I did is I found essentially a line that's perpendicular to the red line and the blue line. That's what we talked about, that if it's perpendicular to one line and the red and the blue are parallel, then it has to be perpendicular to the other. So we know that it's perpendicular to both lines, because any line that's perpendicular to one of two parallel lines, it has to be perpendicular to the other of the parallel lines. Okay? So what I am essentially looking for, again, in terms of this problem, is in order to find the distance, what I need to figure out is the length of this little segment right here. That is going to be the length between the points 0, 3, which I already plotted, and then this point right here of 2, -1. Okay? Now, I can visualize that point on my graph, but I want to show you again, what if you can't visualize it? So if I can't visualize it, what I'm trying to do is find the intersection between the blue and the green line. So what I'm going to do is I'm going to take the blue line, which is 1/2 x minus 2, and the green line, which is -2x plus 3, and I'm going to take the two chunks of this equation, the 1/2 x minus 2 and the -2x plus 3, and I'm going to set those two babies equal to each other. So 1/2 x minus 2 is going to equal then the -2x plus 3. Okay, so I'll start off by combining kind of my like terms on either side. So notice I have variables and numbers. Now we have a fraction here. It's kind of be silly, but I have plus 2x. So let me add that over here. What that's going to give me, think of this as 2.5x, 2.5x. Then what I'd also do is add the 2 to both sides, and I'll get equals 5. Okay? Now to solve for x, I'm going to divide both sides by 2.5. And that means that x is going to equal 5 divided by 2.5, which is 2. So I know that my coordinate of that point is going to be 2 comma something. Now to find out that something, I'm going to take that 2 and I'm going to plug it in. I'm going to take it and either plug it in here for x or plug it in there for x. Now, I don't like fractions, so let's just plug it in right there into the green one. So if I plug it into the green equation, I would have y equals negative 2 times 2 and then plus 3. So then simplifying, I get y equals negative 4. That's negative 2 times 2 plus 3. So therefore, y equals negative 1. So now using my coordinate, I get negative 1. And notice how that point that I solved for here matches the point there. Okay? So this step right here is going to be the hard part, I think, for you guys because it's going back to solving systems of equations we learned about in Chapter 5 because we have to find that point. Again, it's easy to visualize if we get a graph, but if we don't have a graph, then it gets hard. Now we're not done. Holy strawberries, Batman, are we in a jam? So we have the 2 points of 0, 3, and we have 2, negative 1. Our goal is to find the distance between these 2 points. So that means I need to use the distance formula. So that's the square root of, again, x2 minus x1 squared plus y2 minus y1 squared. And again, in my 2 points, I have x1, y1, x2, y2. So plugging them in, the distance would equal the square root of, difference between my x's would be 2 minus 0 squared, plus my y values would be negative 1 minus 3 squared. Okay? All right, now to simplify, I'm going to start inside again. Inside the parentheses, 2 minus 0 would be 2 squared. Negative 1 minus 3 would be negative 4 squared. Then I'm going to square both those things. So 2 squared would give you 4. 4 squared would give you 16. Be careful with that negative there. Notice how it's inside the parentheses. So therefore, I would get the square root of 20. And plugging that into my calculator, again, I want to take the square root of 20. If I ever ask you guys for an exact answer, you can use that. Your calculator might give you this 2 radical 5 business, or decimal form, you're going to get about 4.47. So I'll round that to 4.5. So again, that would be the distance between those 2 lines. So that is a lot, folks. That is a lot of meat and potatoes. But again, what we're utilizing here in these 2 examples, and I'm not going to call them easy examples, but what we're doing is we are utilizing a lot of information that we learned. Okay, so this is a very, I guess, cool problem because we're kind of testing our might in terms of what we know about lines, what we know into different tricks and trades to solve things in order to find the distance between these things. Holy strawberries, folks, I tell you, that's a lot. So that was a lot chopped into that one little video lesson, so make sure if you got questions, jot those things down and ask. All right, good luck on the practice assignment. We'll see you guys next time. Peace out.